Assalamu alaikum students. I warmly welcome to you in the second video lecture series of the physics. In our last video we started the revision of chapter number 5. The first topic we covered in that video was the movement. Now coming to the second topic of this chapter, which is principle of the movements. Before starting this topic, it is important and necessary for us to have general understanding about the device which measures the unknown mass. The device which we are going to discuss is the mechanical device which is known as beam balance, which is used to measure the mass of an object. How does that beam balance work? That it stays horizontal and the masses are being placed on each side of the pivot. When they become same, that's how the mass is being measured. As you can see that a simple diagram of the beam balance has been drawn, and on each side there are placed two masses, which one first one is the uh, apple and second one is the standard masses. Their weights are actually acting downward, which is their action force. The distance are the same from the pivot, and the masses are also the same. That's how the we measure the mass of unknown uh, mass of unknown object. Now for the beam balance to having stability, that as you have seen that in both are at equilibrium state, that both are in stable condition. So the distance between the pan and the pivot should be same. It could be well understood by the simple weighing machine, which is normally the mechanical device which is used to measure the mass of an object. This device is is being normally is seen at the vegetable shops or at the meat shops. What does the shopkeeper does that in one pan it places the noun mass, and in the second pan it puts the unknown mass, and when they becomes equal, that's how the mass of the unknown object is being measured. Now further on, according to the mentioned example of the beam balance, mass of the apple is known, and the standard mass of the pan is unknown. Here in this diagram, the mass of the apple is known, and the standard mass which are being placed in the second pan, which is on the left side, uh, are unknown to us. We will keep adding the masses in the pan on the right side, on the left side, when they become in mass to the equal to the mass of the apple. That's how this beam balance will be in the stable condition. Now for beam balance to be having equal arm, uh, three standard masses will be added in the pan, then both the masses will be equal. So the position of the beam balance will remain horizontal, as we have for previously discussed that the beam stays in horizontal condition. Now their question arises that beam is balanced means no force is acting. We can what we say about two moments. What will happen that there will be producing two types of the movements, that are clockwise movement, and second one is the anti-clockwise movements. In our last video we discussed about two types of the rotation. First one was the clockwise rotation, and second one was the anti-clockwise rotation, and the torque was negative if the rotation produced was the clockwise rotation, and second one was the anti-clockwise rotation, and torque was the positive. So in this the when both the movements will be equal, then we will say that body is in the equilibrium condition. So we will define what will be the principle of the movements. Principle of movement states that when body is in equilibrium condition, means that the sum of clockwise movements about its pivot will be equal to the sum of the anti-clockwise movements. Means that total sum of the movements, means clockwise movement and anti-clockwise movement, will be same. Then we can say that our object is in the equilibrium condition. Taking moments about the pivot, there will be, as the principle of movement states, that clockwise movement will be equal to anti-clockwise movement. So on considering the linear diagram of beam balance, on one side there is being placed apple, and the second, on the right side, there are being placed the standard masses. So we will write their sum of the movements. How we will write this? That weight of the standard masses will be multiplying by the perpendicular distance of the masses from the pivot, and the weight of the apple will be multiplying by the perpendicular distance from to the pivot. We can also write it as its formula as in general form, that weight of standard masses can be taken as W1, and the perpendicular distance of standard masses towards the pivot can be taken as D1, and the weight of the apple can be taken as WT, and the distance of apple to the pivot can be taken as D2. So as the principle of movement states that both the moments will be equal and will be same, so we can write that clockwise movement is equal to anti-clockwise movement, and their general formula can also be will be equal, which is W1 multiplied by D1, and W is equal to W2 multiplied by D2. So as we know that W is equal to mg, and distance is also the same, distance is same, so we can write that mg multiplied by d is equal to 3s g into d. What is the 3s? As previously we have added the three masses in the pen, so that its weight of the pen is equal to the weight of the apple. So here replacing the mass with 3s, the formula of W2 will become 3sg. Upon cancellation, we will be left with m is equal to 3s. So when the beam will be balanced, mass of an apple will be equal to the total mass of the three standard masses. So that was for the discussion. As I can say that it is clear from this discussion that what will be the principle of the movements, and how we can write its general formula for the principle of the movements. Thank you very much.